Hello, hi everyone. Welcome to this Tuned brand. So this is your Siva sir. So this is the previous question which I wrote in the previous class. Okay. So answer to this question. So after this we will discuss about light refraction. So we'll discuss about light refraction. Light refraction. Okay. So let's start about light refraction. First of all, answer to this one. How can you identify the three types of mirrors without touching it? How can you identify? So normally by observing the images, we can identify the mirror. So in plane mirror, what type of image will get in plane mirror? In plane mirror, we'll get a virtual, erect, and so first one is plane mirror. So in plane mirror will get virtual erect, virtual erect, virtual erect and same size. Virtual erect and same size of image will get, right? Virtual erect and same size. Understood or not? Virtual erect and same size. Virtual erect and same size. Virtual erect and same size. And same size. And coming to the second one, concave mirror. In concave mirror will get virtual erect and enlarged. Virtual erect and enlarged. Okay. Virtual erect and enlarged. And coming to the player, so third one, convex mirror. So convex mirror will get virtual erect and diminished. Virtual erect and diminished image will get. So I hope it is very clear. Just check once. See in concave mirror, okay. So plane mirror, what type of image will get in plane mirror? Virtual erect and same size. Virtual erect and same size. And coming to the concave mirror, virtual erect and enlarged. And coming to the convex mirror, virtual erect and diminished image will get. Virtual erect and diminished. I hope it is very clear. So this is about so how can you identify the three types of mirrors without touching it? So like by observing the image nature, we can identify. By observing the nature of the image, we can understand what type of mirror it is. Plane mirror, virtual, erect and same size. Concave mirror, virtual, erect and enlarged. Convex mirror, virtual, erect and diminished. Understood or not? Yes. Now, so refraction. So we'll discuss about refraction. Refraction is nothing but when light ray is passing from one medium to another medium, the path of the light changes at the interference of the two medium. So the path of the light changes at the interference of the two media is called refraction of light. Okay, so you can check here. Refraction, light refraction. So refraction, especially we'll discuss about refraction. Okay, so refraction we'll discuss. So I'm taking this a rarer medium and denser medium. When light ray is passing from rarer to denser, speed of light is more in the medium, that is rarer medium. Speed of light is less in the medium, that is denser medium. When light ray is passing from rarer to denser, when light ray is passing from rarer to denser, at the interference of the two media, the path of the light changes. At the interference of the two media, the path of the light changes. So that is called refraction of light. That is called refraction of light. Understood? So here you can see this the incident ray, okay, incident ray, and coming to the normal line. So this is a normal line, and the light ray which is bending towards the normal line is called refracted ray. This is the refracted ray. Understood or not? Refracted ray, refracted ray. So the angle between incident ray and normal line is called angle of incidence. Angle between refracted ray and normal line is called angle of refraction. So that too light ray is moving from rarer to denser. That too light ray is moving from rarer to denser. If the light ray is moving from rarer to denser, so at the interference of the two media, it changes its path. At the interference of the two media, it changes its path. Okay. So that is the bending of the light ray. And coming to here, so this is the rarer medium, denser medium. Rarer medium, denser medium. Light ray is passing from denser to rarer. Light ray is passing from denser to rarer. So at the interference of the two media, so here the angle between incident ray and normal line is called angle of incidence. Angle between refracted ray and normal line is called angle of refraction. Angle between incident ray and normal line is called angle of incidence. Angle between refracted ray and normal line is called angle of refraction. Angle of refraction. So here in the first case, case number 1, in case number 1, so this is case number 1. In case number 1, so you can observe angle of refraction. So angle of incidence is greater than the angle of refraction. Angle of incidence here, this is greater than this one. Compared to this one, this is greater, because when light ray is passing from rarer to denser, it bends towards the normal line. When light ray is passing from rarer to denser, it bends towards the normal line. The angle between incident and normal line is called angle of incidence. Angle between refracted and normal line is called angle of refraction. Angle of refraction. Okay. So angle of incidence is greater than the angle of refraction. And coming to the case 2, in case 2, you can observe angle of refraction is greater than the angle of incidence. Angle of refraction is greater than the angle of incidence, because so when light ray is passing from denser to rarer, it moves away from the normal line. Speed is increasing. Speed is increasing. That's why it is moving away from the normal line. So angle of refraction is greater than the angle of incidence. Understood or not? So these two are very, very important. Okay, so when light ray is passing from rarer to denser, it bends towards the normal line. If it is moving from denser to rarer, it moves away from the normal line. The reason behind of this is, so when it is passing from rarer to denser, in the denser medium, speed of light is less. So when it is passing from denser to rarer, so in the rarer, speed of light is more. Okay, in the rarer medium, speed of light is more. In the denser medium, speed of light is less. And one more thing, refractive index is more for denser, more in denser medium. Refractive index is more in the denser medium compared to rarer medium. Okay, so these are the reasons. That's why. And coming to loss of refraction, so we'll discuss about loss of refraction. Loss of refraction. Okay, so here now we will discuss about loss of refraction. Point number 1. Point number 1. First point is loss of refraction. Loss of refraction. Okay. Loss of refraction. Loss of refraction. Loss of refraction. Loss of refraction. Point number 1. Incident ray, refracted ray, normal line lies on the same plane. Okay. So incident ray incident ray, refracted ray, normal line lies on the same plane. Coming to the second one, so the ratio of sine of angle of incidence to sine of angle of refraction equal to constant, that is nothing but refractive index. The ratio of sine of angle of incidence to sine of angle of refraction equal to constant, that is nothing but refractive index. So here there are two types of refractive index are there. One is absolute refractive index, another one is relative refractive index. Absolute refractive index, absolute refractive index. Okay, absolute refractive index is, so n equal to c by v, n equal to c by v, the ratio of speed of light in vacuum by speed of light in medium. So absolute refractive index is nothing but the ratio of speed of light in vacuum by speed of light in medium. Okay, so coming to the next one. Next one, so relative refractive index, relative refractive index, relative refractive index, refractive index, relative refractive index, that is nothing but n12. So if you are taking n12, we can write n1 by n2, n1 by n2, that is nothing but v2 by v1. So if I take n21, that is nothing but n2 by n1, that is nothing but v1 by v2, because n is inversely proportional to velocity. N is inversely proportional to velocity. That's why n is inversely proportional to velocity. Understood or not? Refraction is nothing but when light ray is passing from rarer to denser, at the interference of the two media, the path of the light changes or direction of light changes. So it bends towards the normal line if it is passing from rarer to denser. If it is passing from denser to rarer, it moves away from the normal line. It moves away from the normal line. Coming to laws of refraction, incident ray, refracted ray, normal. Incident ray, refracted ray, normal line, so lies on the same plane. The ratio of sine of angle of incidence to sine of angle of refraction equal to constant. That is nothing but absolute refractive index. So that is refractive index. So n, coming to absolute refractive index. So absolute refractive index is nothing but the ratio of speed of light in vacuum by speed of light in medium is called absolute refractive index. So n is inversely proportional to velocity. Coming to relative refractive index, so n12 equal to n1 by n2, that is nothing but v2 by v1. So n is inversely proportional to velocity, and n21 equal to n2 by n1, that is nothing but v1 by v2. I hope it is very clear. So this is about absolute refractive index, relative refractive index, laws of refraction, and refraction of light. And coming to the one more, so one more we will see, that is next one. Okay, normally what happens when the light ray is passing from denser to, so this is the rarer medium, this is the rarer medium and denser medium, rarer medium and denser medium. So normally what happens if the light ray is passing from denser to rarer, it moves away from the normal line. So I am taking this the source, this is the source. Okay, so I am taking the source. Light ray is coming from denser to rarer. So this is a normal line. This is a normal line. What happens? It moves away from the normal line. So this is the angle of incidence and angle of refraction. Angle of incidence and angle of refraction. So if the light ray is passing from denser to rarer, so I am taking this a normal line. If it is normal line, this is the angle of incidence. And see normally, so I am taking this the rarer medium, denser medium. You keep on sending the light ray. So what is the refraction? Refraction is nothing but, so the path of the light changes at the interference of the two media. And keep on sending the light ray at certain angle, the light ray passes or gauges or moves along the surface. Along the surface. Okay, so the light ray passes or gauges or moves along the surface or along the interference. Understood or not? So I am taking here. So at this point, the light ray passes. So along the surface, okay, or making 90 degrees with normal line. Refracted ray making 90 degrees with the normal line. Okay, so angle at which the refracted ray making 90 degrees with the normal line, that is called critical angle. Critical angle. The angle at which the refracted ray makes 90 degrees with the normal line is called critical angle. Understood? So, and one more thing. So, the light ray I'm sending from denser to rarer. Okay. So, if it is sending, so the light ray will reflect back, or making more than 90 degrees. So, here is 90 degrees plus theta. Okay. So, it is more than 90 degrees. The refracted ray makes more than 90 degrees, and that light ray reflect back into the same medium. So this phenomenon is called total internal reflection. Total internal reflection. Understood or not? Once again, light ray is passing from denser to rarer. So at the interference of the two media, it changes its direction. So that is normal refraction. So when the light ray is passing from denser to rarer, at the interference, it makes 90 degrees, or it passes along the normal line, or it gauges along the normal line, or moves along the surface, or along the interference. Okay, so this is the interference between rarer to denser. Okay, rarer and denser. So it is moving along the normal line by making 90 degrees with the normal line. So that angle is called critical angle. I understood. I hope it is very clear. So and the next one, light ray is moving from denser to rarer. Okay, so it in the rarer medium, it making more than 90 degrees, then it will be reflected back into the same medium. Then this phenomenon is called total internal reflection. I hope it is very clear. So these are the 2 points. Understood? Next one. So next one is about glass lab. So here is a glass lab. Okay, so light ray is passing from rarer to denser. This is a rarer medium and denser medium. Light ray is passing from rarer to denser. Okay, at this interference, it bends towards the normal line. So it bending towards the normal line. And again, so at this position, it is moving away from the normal line. So if you are extending this light ray, so the distance between emergent ray and initial direction of the incident ray is called lateral shift. Okay, so lateral shift. Understood or not? So the distance between emergent ray and extended incident ray or initial direction of the incident ray is called lateral shift. So this diagram they will give for 3 marks. So very important question. Okay, so this is the incident ray. And coming to this one is the refracted ray. And coming to the next one, emergent ray. emergent ray. So the angle between incident ray and normal line is called angle of incidence. Angle between refracted and normal line is called angle of refraction. And angle between emergent ray and normal line is called angle of emergence. Angle of emergence. Understood or not? So the distance between emergent ray and initial direction of the incident ray is called. So what is this one? This one is called lateral shift. Lateral shift. Understood or not? I hope it is very clear. Now coming to the vertical shift. So here you can observe. So this is the beaker. So coin is placed. So beaker, coin is placed. I hope it is very clear. Coin is placed. Understood? So when you pour water, if you pour water, so this person can't able to see the initial position, this position after pouring water, the coin position rises up. The coin position rises up. So this is the apparent position and this is the actual position. This is called vertical shift. Vertical shift. The distance between actual position to apparent position of the object is called vertical shift. Understood or not? This is the vertical shift and this is the lateral shift. So even if you place the pencil in the beaker, so if you are placing pencil in the beaker like this, so water is here. So I am placing the pencil over here. So this is the pencil like this. So actually at this position, it appears to be bent. So here it appears like this. It appears like this, appears bent, but actual position is here only. Okay, so due to refraction of light, even if you place a lemon inside of the beaker, it appears bigger. So if you observe, when you go to the shop, okay, so near to the shop, so in front of the shop, like so near to the, okay, to the cashier table. So this lemon they will place, it appears bigger. Okay, it appears bigger like this. It appears bigger. Okay, this is due to refraction of light. Understood or not? I hope it is very clear. So this is about refraction of light. Next one. So we'll discuss few problems. Okay, related few problems we'll discuss related to refraction. Okay, let's start. So a few problems we'll do it. So let's start doing problems. So this theory question I'll write once. So it's very important. So we need to discuss, that's right. Okay, so just check this question. If you know the answer, you can write. So question number 1. What are the factors? What are the factors on which on which on which the lateral displacement the lateral displacement the lateral displacement the lateral displacement of an emergent ray of an emergent ray emergent ray from a glass slab from a glass slab depends. So can you tell me on what factors, so check this question, on what are the factors on which the lateral displacement of an emergent ray from a glass slab depends? So can you let me know the answer if you know it? So very, very important. Just check once. So let me know that. Check once. What is the answer for this question? Okay. So what is the answer? So coming to the answer is, first one is thickness of the glass slab. Thickness of the glass slab. Thickness of glass slab. And the second one is Refractive index of glass slab. Refractive index of the glass slab. Index of glass slab. Refractive index of the glass slab. And third one is the angle of incidence. The angle of incidence. The angle of incidence. Okay, so these are the points. The angle of incidence. So these are the points. Check once. If you have any doubts, let me know. I hope it is very clear. Okay. So what are the factors on which the lateral displacement of an emergent ray from a glass slab depends? Thickness of glass slab, refractive index of glass slab, the angle of incidence. Understood or not? Next one. One more is, so this question is very important. Try to solve this question. So what is meant by refractive index? What is meant by refractive index? Okay, question number 1. And if the speed of light in a medium is 2 by 3 of the speed of light in vacuum. Okay, so find the refractive index of that medium. Okay, so can you identify the question? Identify and try to answer it. Okay, so what is meant by refractive index? If the speed of light in a medium is 2 by 3 of speed of light in vacuum. Okay, find the refractive index of that medium. So that is a question. Try to answer it. So what is the answer? If anyone knows, let me know the answer. Okay, very good. Answer is 3 by 2 is correct. So here you can observe. So what is meant by refractive index? Anyway, speed when light ray is passing from one medium to another medium, the path of the light changes at the interference of the two media. So what is the refractive index? The light ray is passing from one medium to another medium. So path of the light changes at the interference of the two media. That is called refraction of light. The speed of light in vacuum. So speed of light in medium is given. So V equal to 2 by third of C. Okay. So given, this is given that. Given data. Okay, so given data. Now normally, so formula absolute refractive index, because sir, why you are asking, why you are taking absolute refract? Because they compared with the vacuum, speed of light in vacuum. Okay, so speed of light in vacuum. So that's why we have to take n equal to C by V. So C by V. Then C by V equal to how much? 2 by 3 into C. C get cancelled, you will get reverse of 2. So n equal to 3 by 2 is, that is nothing but 1.5. So n equal to 1.5 refractive index. So that is the refractive index value. Understood? So like that you have to solve. Is it correct? So let me know the answer. Is it correct or not? Okay. So next one. We'll go to the one more question. So one more question. Try to solve this question. Okay, try to identify this question. The answer to this question. The refractive index of air with respect to glass is 2 by T, and So concave mirror image will form at center of curvature. That is nothing but 2f only. Okay. So let me know the answer to this question. So here you can see they mention the refractive index of air, with respect to glass. Refractive index of air with respect to glass is given. Okay. So refractive index of air with respect to glass. So I'm writing n with respect to glass. So I'm writing n air with respect to glass is 2/3 given data, and refractive index of water with respect to air, equal to 4/3. So the speed of light in glass is, speed of light in glass is 2 into 10 power 8 meter per second, and the speed of light in air and water, speed of light in air and the speed of light in water we have to find out. So that is a question. So for that what we have to do? So first we have to find out. So take this one, N A G, if you are taking Na by Ng equal to into, so Vg by Va. So we can take refractive index formula. That is nothing but N A by Ng, that is nothing but Ag. Okay, so that is equal to, from here, Vg by Va. So we know that Na by refractive index is 3, and the velocity of the glass, okay, that is 2 into 10 power 8 meter per second by Va. Okay, so cross multiply. If you cross multiply, you'll get Va equal to 2 into 3 into 10 power 8 by 2. So 2 to get cancelled, then 3 into 10 power 8 meter per second is correct. Okay, velocity of the air is correct. So that is, velocity of the air is 3 into 10 power 8 meter per second. Right, velocity of the air is 3 into 10 power 8 meter per second. And coming to the velocity of water we have to find out. So that is Nw by Na equal to Va by Vw. Okay, so that is 4/3. So Va equal to 3 into 10 power 8 meter per second by Vw. So cross multiply. Vw equal to 3 into 10 power 8 by 4. So Vw equal to velocity of the speed. So speed of light in water equal to, so 9/4 into 10 power 8. That is nothing but, so how much you'll get? So sequence. You let me know the answer. Let me know the answer, how much you'll get. So the answer is 2.25 into 10 power 8 meter per second. Okay, 2.25 into 2.25 into 10 power 8 meter per second. That is velocity of water. Understood? Is it clear or not? So check once here. This is the answer. Velocity of water is, so speed of light in water. Is it clear? So is it correct? Let me know the answer. Is it correct or not? Okay. Yes. Yes, ma. So Chirag, even SSC or CBSE, so I thought 2 boards. So SSC and CBSE also I thought. The both boards, the diagram is same and the object is placed at 2F. Image also will form at 2F only. Okay, in concave mirror. nature of the image is real and inverted, and size of the image is same size. Okay, say same diagram, so you can check once. So diagram is same, no change at all. So concave mirror only we are taking. Okay, so next one, so we'll discuss one more. So one more question. So you have exams in March, right? February. For SSC students, you have exams on March 14th onwards, right? Okay, so you can join. It will be helpful, those topics. Okay, one more question. Okay. So that state. Okay, fine. So absolute refractive index. Define absolute refractive index of medium. Can refractive index of medium will be less than unity or not? Refractive index. What topic is going here? So we are discussing light reflection and refraction. Sir, hi. Yes, class 10 science. Class 10 science. Light reflection, refraction. CBSE grade 10. So 25th exam is there. That's why we are working on physics. Okay, one more question. So what is the value of now? So what is the value of n to 1 into n to 1? So what is the answer? Let me know the answer. So this is the last question. So again we'll continue the class after some break. So after taking break, we'll continue around 6 o'clock. Okay. Thank you so much for joining and attending the class. So we'll see in the next class. Okay. So thank you so much. So if you know the answer, you can let